Hey there. Today I'm diving into a crucial topic for all you data scientists out there. Key concepts in machine learning. Let's break it down with training versus test sets and more. First up, datasets training versus test sets. In machine learning, data is divided into subsets to help ensure your model can generalize to new data. The two main subsets are training sets and test sets. This is the data used to train your model. The model learns patterns, structures, and relationships from this data. During training, your algorithm adjusts its parameters, like weights in neural networks, to minimize prediction errors. Once your model is trained, you'll need to evaluate its performance on unseen data. That's where the test set comes in. It helps estimate how well your model generalizes to new data. If your model does well on the training set but poorly on the test set, it's probably overfitting. Sometimes you might also use a validation set to fine-tune your hyperparameters before testing on the final test set. Next, let's talk about features and labels. These are the input variables used to make predictions. For instance, in predicting housing prices, features might include the size of the house, number of bedrooms, or location. These are the output variables or targets the model aims to predict. In our housing price example, the label would be the actual price of the house. In classification problems, labels might be categories like cat versus dog, while in regression problems they're continuous values like temperatures. Now on to overfitting and underfitting. This happens when your model learns not only the general patterns but also the noise in the training data. An overfit model does great on the training set but poorly on the test set. For example, fitting a 10-degree polynomial to a small noisy dataset will capture every detail, including the noise. The training error might be low, but the test error will be high since the model can't generalize well. This occurs when your model is too simple and fails to capture the underlying data structure. An underfit model performs poorly on both training and test sets. For example, using a linear model to fit data with a clear nonlinear trend will lead to high errors because the model can't capture the nuances. So what's the goal? It's finding the right balance between underfitting and overfitting, ensuring your model has a good bias-variance trade-off. To avoid overfitting, you can use cross-validation, regularization, simplify your model, or prune decision trees. By mastering these concepts, you'll be well on your way to building models that generalize effectively to new data. Thanks for sticking around. If you found this helpful, hit subscribe and stay tuned for more machine learning insights.